Imagine this. You walk into a laundromat and a robot has been folding laundry nonstop for 24 hours. That's what Jason and his team is working towards. Fully autonomous, single task, commercial grade robots. Which is just a fancier way of saying the robot does one thing very well without needing human intervention. And they just raised $120 million in order to get there.
Our goal is to power the future of the physical economy. Getting these robots to be very robust and can sustain a long duration of actually doing a task is a technical barrier that hasn't been really solved before our work. Very important to have a good taste for what are the right problems that you should have your robots solve. At the present moment, the bottleneck for useful robots is AI and software. These humanoids right now, they're not actually very useful, and the cost and the hardware readiness is a big factor. The best way to succeed is to build research and product at the same time.
Quick thing before we get started, we have a lofty goal this year of hitting 1,000 subscribers in order to help more people build really great companies. So if you enjoy the content, learn something new, the best way to support us is by subscribing. Okay, let's get into it. Today's guest is Jason Ma, one of the brightest minds in robotics. He's the lead author of multiple award-winning papers recognized internationally for his research. He had offers to return to Google DeepMind, NVIDIA, Meta, but turned them all down to start Dyna Robotics. And now, instead of chasing sci-fi humanoids, robots that look and move like humans, he's building robots that actually work, folding towels, stacking, packing in the real world. So Jason, thank you for joining me at Founders in Motion today.
Thank you, Thea. Thanks for inviting. Really happy to be here and nice catching up with you after so long.
Yeah, this is an interesting change of scenery for us. Jason, in very plain English, what is Dyna Robotics building?
At Dyna, we're building general purpose robots that power the future of physical economy. So the way I think about it is that we're developing AI-powered robots that can do any task in any business or home scenario. And to start out, we have deployed our robots using AI in many different scenarios, such as restaurants, gyms, fitness centers, etc. And our mission is to make these robots and our AI model as general as possible, so you can basically do any task that you want it to do.
So when it comes to robotics, there are kind of typically two approaches that people usually go for. So the general purpose, everyday kind of companion supportive robot, or the very fancy humanoid, move and feel like humans. So why did you decide to start with everyday tasks like folding towels instead of going after kind of the overarching humanoid dream?
Yeah, so our eventual goal is to develop a robot that can do any task, right? So to that end, perhaps at some point we'll venture into humanoid robots. But it is our belief from my past experience and also research that humanoid robots as hardware is not currently mature, and it's way too expensive. But I think at the present moment, the bottleneck for useful robots is AI and software. So we decided as a company to first focus on off-the-shelf hardware. So basically, these are robots that you can buy off the shelf, couple $1,000s, and then we develop the AI on top of it so it can be already useful. So you might have seen some of our demos. Our robots can already fold napkins, fold clothes, do packaging at very, very high success rate and robustness. And I think that's a stepping stone towards developing the more human-like, form factor, if you will. Because if you look at these humanoids right now, they're not actually very useful, and you could only see them behind a screen instead of actually seeing the robots in action in front of you. And the cost and the hardware readiness is a big factor.
Yeah, that's super fair. And so folding laundry seems like a very simple task for humans. Why is it actually so hard for a robot to do?
First, I think folding laundry is also fairly challenging for humans. For one, it's very mundane and tedious, right? Like I don't like doing my laundry, and I think for cloth garments, they come in all different shapes, types, shirts, jeans, long sleeves, jackets. And what's really hard about robots, why is this hard for robotics, is for a couple of reasons. So one, just taking a step back, right? traditionally you have robots as automation tool. You see robots in factory. And
Yeah.
what happens is you pre-program robots exact sequence of motions, right? So for instance, you want the robots to package into like a box of things you want to deliver. It's a pre-programmed sequence of motion. But that's actually very difficult to do for something like folding laundry because your clothes is like deformable, right? The shapes are
Mm.
always different. They're not in like perfect, rigid shapes and states. So it's really hard to pre-program a sequence of motion to fold cloth for you. And what that means is you really need to develop, using generative AI tools, right? Just like language model, ChatGPT can really do anything based on your language command. You want to develop AI models that can control robots to do very fluid and dynamic motions, just like how human arms are very fluid and dynamic and do many different motions to fold clothes. So that is why this task traditionally has been very difficult for the preceding paradigm of robotics, where you pre-program the motions, and now it's actually more amenable for the new wave of robotics, which is learning robot actions through like data, right? You learn from data. Yeah.
Yeah. And if we take a moment to dive a little bit deeper um, into the technology behind all of this, I guess at a high level, how do you think about training these generative models to help robots recognize different outcomes in the real world or different
Yeah,
inputs in the real world?
yeah. So the way we train it is very much like how humans interact with the physical world, right? So like for us, we have our eyes that
Yeah.
perceive the world through vision, through perception, and then
Hmm.
we use our brain to turn these sensory, image inputs to our eyes into like actions that our arms and our legs perform, right? So very
Yeah.
much, for training these robots, it's like we have cameras on the robots that perceive the physical world, and then we
Hmm.
train neural network to output actions, or like actions that command the robots, joints and different motors on the robots. So the way to do this is, you collect input-output pairs of images in and robot joints out, right? So you can basically control the robot to fold clothes many, many times to collect data, and then that data gets fed into a model, which then can control the robot autonomously.
So you're essentially kind of building your own general purpose data models and data sets in order to train these folding laundry robots.
Yeah, basically. Yeah, but you see the paradigm here is fairly general, right?
Yeah.
Uh, it's not really specific to laundry folding. So if you have
Hmm.
data that you collected for, let's say, packaging, for cooking a meal, for cleaning your bedroom, then the robot using the same algorithm can train models that can do these tasks. And what's really interesting is that you can actually just combine all the different data sets for different tasks into one model. Then that model becomes very powerful, right? Just much like language models today. It's not just one model that does one particular language task, but one model that can chat with you, write code for you, and do many other things. So that's like the vision that we're also trying to do for robotics. But there's of course a lot of nuance, which we can get into later as well. Yeah.
Yeah, super cool. I think I read on your research somewhere that there's a high adaptability from use cases from one to another. So the next use case should be trained at a lighter weight and then continuously forward. So you ran this super cool 24-hour napkin
Yeah.
test, nearly 800 folded with 99% success rate. For someone who's not technical, why was that such a breakthrough?
The reason why that result was very difficult and very impressive in the research community, robotics community, is that we have seen, you probably have seen a lot of demos recently of robots doing cool stuff. But typically, what happens is that those demos are very brittle. It took many, many shots to get even one video that works very well. So basically,
Mm,
robots are now at a place you can shoot fancy videos, but actually getting these robots to be very robust and can sustain a long duration of like actually doing a task is a technical barrier that hasn't been really solved before our work, especially for these highly dexterous, complex manipulation tasks such as folding laundry or folding napkins, right? And
yeah.
so that is why this result was very different in that it's a result where we across a span of a week, we shot many 24-hour video of the robot just continuously folding napkins nonstop for 24 hours, hundreds of napkins folded without much failure at all. And that was very different than prior works where, yes, you can get a robot to do a laundry folding demo, but the success rate is often like about 70% or 80% success rate. So that means
Yeah.
if you try to fold 10 t-shirts, it might only succeed 8 times. So that's good
Mm.
enough for a demo, but it's not good enough for actual real world deployment, right? Because if you imagine your robot only succeeds 8 out of 10 times, that would be a very frustratingly bad robot, right? So at Dyna, we are very much focused on not just putting out fancy demos, but actually developing the AI technology to power like what actually can work in the physical world. Yeah.
Yeah, and for anyone that is a little bit confused, it's okay because I
Yeah.
printed all these terms in case Jason ever mentioned them. But dexterous manipulation is basically just teaching robots to use their hands as flexibility as we do. So folding, gripping, managing weight, twisting without breaking things.
Mhm.
And okay, while you were training the robot to get to this very high level of success rate, what's like one funny or surprising failure that the robot had before it finally nailed the test?
For the napkin example in particular, what was very, very difficult is like actually, so what happens at a real restaurant is like they'll give you a stack of napkins for which you have to fold the napkins one by one. So the
Yep.
robot initially would make the mistake of like pulling out many, many napkins from the stack, right?
Mm,
And then now you have a whole big mess on the table where tons of napkins are at the center of the table, and then where you're only supposed to fold one. So that was a very tricky scenario that the robot got into early on. But we were able to basically train the robot to handle those scenarios. So whenever it grabs multiple napkins, then it would put the extra ones back onto the stack. But then that creates a pretty messy stack on the side. So the robot then had to figure out how to deal with that situation. But eventually, our robot was able to get around all these tricky scenarios and become very, very good. But just from this example, you probably realize, real world physical AI, like embodied
mm,
AI, basically teaching robots to do things is actually very complex. If you handle one scenario well, there might be other scenarios that you didn't expect that a robot has to handle that comes up. So it's kind of like, whack and mole, like just because you handle one scenario doesn't really mean other scenarios are handled very well, which is why physical AI is often very, very challenging. And as our model got really, really good, another fatal case is it pulls the napkin too fast. So the napkin just slid off the table. But besides
ah,
those scenarios, yeah, the robot was pretty much like 100% in folding a napkin that's present in front of it.
there's so many different edge cases in the human world to deal with. And
Yeah.
embodied AI here is just AI inside a physical body. So, like a robot arm that can see, decide, and act in the world. I wouldn't say I'm technical, but like I studied a little bit of technical stuff. So, like,
Yeah.
this
Yeah.
is really fun for like the nerd in me.
Yeah.
Um, so I also wanted to talk about that approach a little bit. So Dyna
Yeah.
1 is both the arm, so the body, the actual physical arm, and the AI, the brain of it. So why is it so important to kind of build them in conjunction almost rather than just like building like a general purpose AI brain that can be applied for any different type of physical embodiment?
The way we think about this is that physical AI is extremely hard, especially if you're interested in pushing real world performance, right? So if you
Hmm.
think about like pushing real world performance, then it's a matter of both the software and hardware. Like if your
Yeah.
hardware like always breaks, your robots are just not good enough, then you can't actually run an AI model on the robot for 24 hours, right? So previously
Yeah.
when I was doing research in the lab, we often ran into the issue that the robots would break after a couple hours, or like you have to maintain it, or the robot would start overheating after like 5 or 6 hours. So it's just even physically not possible to run for 24 hours. So from
Yeah.
that simple thought exercise, it's probably more clear that in order to get to any real world performance, you have to do software, hardware co-design, co-iteration. But that
Mm.
said, though, in Dyna One, the arms themselves were something that we bought off the shelf, but we had to do a lot of things on top of it to make it more durable, more just has higher endurance. So we could even try running a model for 24 hours. And during
Yeah.
the early days of the research, it's certainly the case that the model would do something like more violent, like maybe it would
Mm.
hit the table very hard. So that makes it even more important
Yeah.
that the hardware is good enough. But what I find interesting is that traditionally robotics would have a lot of safety features or safety layer, like you program the robot to be safer. But in the AI age, what we found is that the models are more intelligent. It actually just does more, dexterous, smooth behavior. So it's much less likely to even do the unsafe behavior in the first place. So
Yeah.
that made hardware reliability also just a much simpler problem than before.
One point that you mentioned I thought was super interesting is that like
Yeah,
even though you bought the hardware off the shelf, it still went through a lot of iteration um, to ensure that it could even operate in 24 hours,
yeah.
which kind of double double ends the point of like maybe hardware is the bottleneck for humanoids and that kind of more advanced application of robotics. Why did the team choose kind of an application like folding laundry, folding napkins as the first test case use case to play with?
One is that like if you want to use a more AI, like data-driven approach to train robots, then it's very important that you have a lot of data, right?
Yeah.
And folding clothes, folding napkin is a scenario where you couldn't really like break the object that you are like teaching a robot with, right? Like,
Mm.
clothes is like napkins are soft, so like you couldn't really like mess it up. But
Yeah.
there were other applications we looked into, like for instance, like loading dishes, right?
Mm.
But there, the safety risk is a lot higher. If the robot messes up a single time, like it drops a dish, then the dish break. To advance model capability, we start out with some task that has the feature where like you can just have the robots practice, try many, many times. And like
Yeah.
clothes folding laundry was like the perfect scenario because once you fold it very nicely, you can just like disturb it so the cloth gets like crumpled again so you can have the robot practice again, if you will, right? So that was from a technology perspective very appealing. But from the business side, it's also the case that there's a huge demand actually. Like we don't even think about folding napkins in restaurants, but if you go to like, I don't know, like Cheesecake Factory, Applebee's of the world, there are just so many like napkins that need to be folded in the back office all the time. So it's almost like a full-time employee's job. Like their whole job is to do that. So we thought there's a huge need to like do this kind of tasks to get started. Yeah.
Yeah, I mean, I think folding napkins is a universal experience across all restaurants.
Yeah.
And also, even folding laundry is such a pain too. I am also
Yeah.
not a big fan of it. You've moved from control tests to doing some kind of pilots in the real world. So, when you move from like a lab setting to, say, a local laundromat, what new challenges pop up?
What we didn't realize is that in the office, first of all, like we have air conditioning, so the room was like kind of cool. But like in a lot of
Yeah.
these real world scenarios, you
Hmm.
do not have control of the temperature. So like overheating becomes more severe. You also
Yeah.
don't have good control of the network. Laundromats don't necessarily have the best Wi-Fi, right? So
Mm.
if you think about like running models over cloud, then Wi-Fi becomes a bottleneck. Where if you're doing some data collection on site, then uploading data also becomes a lot slower. Then there's the operation challenge. Like, how can we trust to put a robot in a real customer site and not worry about something goes catastrophically wrong, right? Like, for instance, like the robot's putting napkin in the back office, but you don't want it to like catch on fire by accident. That's the hard part of robotics. It's not just like getting AI to work. You also have to like make sure the deployment flywheel goes smoothly.
For a business owner, like how does the math work? how are you kind of thinking of pricing these robots and when do they actually pay for themselves?
A lot of these businesses are quite price sensitive, or like they're operating, you know, it's a spectrum, but let's say like, restaurants are perhaps low margin businesses. So
Mm-hmm.
we realized that in order for the economics to make sense at all, like your robots have to be somewhat cheap, right?
Mm-hmm.
So this is also why, like when you were mentioning humanoids, we don't think it's ready because any humanoids you can buy, or first of all, you can't buy that many, but the ones you could buy are also in the orders of like tens of thousand, 20,000, if not more, right? But our
Yeah.
robots are like a couple grand each. We do like a robotics as service business model. So we don't like actually sell the hardware. We just rent the hardware out to different customers, several grand a month to rent a robot. So it's actually like on par, if not cheaper than like typical labor cost in the United States.
When you think about the next application for Dyna, um, what is the team kind of actively testing with right now?
Our goal is to power the future of the physical economy. So basically, any task that we think is extremely mundane, dull, dirty, dangerous for humans to do, we're looking into it. Looking into many different markets. So, of course, hospitality, right? Like
Mm-hmm.
hotel, restaurants, we're discovering use cases. Then, the laundromats of the world, the logistic warehouses of the world. The most important thing is just like develop a general recipe. So we could actually just deploy our models to any scenario that we want.
Moving into a bit more about your founder journey.
Yeah.
So you could have gone back to DeepMind, NVIDIA, or Meta. And if you only knew the eye-popping number that they gave Jason, but I don't think I can say. Um, but instead, you chose the riskier founder path. What
Yeah.
made you take that leap?
The best way to make an impact in robotics is at a startup. Robotics is an extremely complex problem. It's not just a software problem. So you wanted to have the freedom, the velocity to do all the things required to get robots to work. And I
Yeah.
firmly believe that getting robots to work requires you to actually deploy the robots in realistic, real scenarios, right? And I think that's just not possible to do at a big corporate lab where
Mhm.
robotics is like a research problem to them, but not
Yeah.
necessarily something they want to solve right away, right? Like all the companies you mentioned, their core businesses are not robotics, and their core AI is not in robotics at the moment, right? They're developing big language model, whatnot, to power their platforms, right? Competing with let's say OpenAI, Anthropics of the world. So
Yeah.
robotics is more like a research problem for them. But I felt that it's possible to actually get robots to work in the real world with the right team, the right mindset, and there's enough funding that's willing to fund this kind of startup now. So I thought it would make a lot of sense to start Dyna.
So you've always been kind of on the more research side. So
Yeah.
moving into startup and more of the business realm of things, what's one lesson that you've learned that really surprised you?
For robotics in particular, it's very important to have a good taste for what are the
Mm,
right problems that you should have your robots solve. There are so many robotics companies in the past that perhaps picked a problem that's too hard or like too costly. So it's actually very, very hard to penetrate the market and to succeed as a business. And
yeah.
that's also, and hardware is also just innately expensive. So there's been a history of like venture capitalists don't really like funding hardware companies for that reason. In research, the most important thing in my opinion is also research taste. Now, how do you pick a good research problem to work on? What happened in the past is a lot of robotics company went really deep in a vertical, so all their solutions, their software hardware stack becomes very specialized in that domain. So you cannot just go
Yeah.
from one domain to the other. So that's the kind of thing we don't want to do at Dyna.
What is like your two-sentence pitch for why Dyna is different from other robotic companies?
At Dyna, we do both the research and also the product. And I think
Mm,
the best way to succeed is to build research and product at the same time, right?
mhm.
So you can think of, let's say, like, ChatGPT, right? It's a product that you can use, right? But there's also a lot of research that goes behind it to make it well. And I think the feedback loop from product to research and from research to product is what makes the existing AI products on the market like so good and so sticky. So you look into robotics, there are companies that's purely trying to take some existing technologies and turn it into a product. But I think right now, the existing technology, just as it is not ready to get to general purpose like manipulation, right? Like using arms, hands to do things. But at the same time,
Yeah.
if you're only focused on research, then I think sometimes you're focusing on problems or like tasks that may not really be representative of the real world tasks, right? Because there's always a gap between research and actual deployment. So as a researcher, certainly in my research papers and all that, all the tasks I were solving are like toy versions of the real world tasks. But at Dyna, we go straight to like the real version of the task. So we know that if our research is good enough to solve those tasks, we can immediately turn them into product. That feedback loop makes our technology and business much more solid.
Research is always theoretical. Like the name of it is
Yeah.
about being very theoretical. So
Yeah.
iterating it within deployment and within testing is very important to make it actionable. Throughout this journey, what has been the most valuable lesson that you've learned? Something that you really wish someone had told you earlier?
Building a startup is actually quite hard. Yeah,
Really?
I think it's been a year. I think it's definitely harder than like when I did my research or PhD. Because in PhD, I was really just minding my own business, my own research. So like, there's not that much else I have to worry about besides the existing research. For a company like Dyna, we were really trying to develop like full stack robotics, right? Going from hardware, software, AI, everything. Then there's always many things moving at the same time. Not only just excel at what I already do, which is AI research, but also coordinate, collaborate with many different teams and to make sure we're always being able to prioritize the most important things in the company and allocate resources accordingly. And I think that's definitely like a shifting gear compared to previously when I was just doing my research.
Shifting gears from like an independent contributor to like a leader is always very hard. Okay, so Jason, the way that we like to end these things is we like to play a quick game. So since you're on the frontier of robotics, I want your predictions. So in 10 years, who will be doing these jobs? Robots or humans? Flipping fast food burgers?
Robots.
Delivering packages to your door?
Robots or humans? I think you get to choose, or you should be able to choose.
Teaching kids in classroom?
Humans.
Walking your dog?
Humans. Or robots. I've seen videos of robot dogs walking like real dogs.
Performing surgery in a hospital?
Humans. Surgery is where like safety is so important, and I think the precision required, there's a lot of research papers on surgical robots, but I feel that this is one area I would be like very careful. So I would still trust a human surgeon than robots. Or maybe, maybe Dyna will solve it one day. We don't know. We'll see. Yeah.
We don't know. I mean, I'd also think it's like depending on the application, right? Thank you so much for coming on the show. I really enjoyed the conversation, learned a lot more about robotics.
Yeah, thank you for hosting and having me.
That's a wrap. If you like this episode, please hit the subscribe button. It helps us bring on more awesome guests, level up production, and drop new series you'll want to watch. See you in 2 weeks.
The robot's very meticulous. It'll fix all the it's gonna try to bring the sleeve out before it goes to the folding stage. And sometimes it's very delicate, so the robot has to try a couple times. Let's see if it recovers from that. Okay.
Go, robot.
Yeah. Oh, there we go. Right. So it's gonna stretch it out, and so some of our employees used to work at Facebook, so that's why here's a Facebook shirt, as you'll see.
Boo.
Yeah. So.
Wow.
Yeah. I think folding laundry is hard. If I were to fold laundry, it's not this good. Like this square. Let me